Welcome to example number 4. This question involves the intensity of a sound wave, and that's given here as I equals 2.0 times 10 to the power of negative 3 watts per meter squared. That it is perceived to be modestly actually low here. The eardrum has a diameter, so the radius is going to be then half that diameter, 3 millimeters, which I'll convert to meters. That's 3 times 10 to the power of negative 3 meters. And we're asked to find out how much energy would be transferred to your eardrum while listening to the sound for 1 minute. So T equals 1.0 minutes, which is basically 60 seconds per minute, so 60 seconds. So in order to solve for this, we need to know the relationship between the intensity is really the power divided by the area. And the power divided by the area is, since we're looking at an eardrum with a certain radius, we're going to be looking at the area of that circle, and that's basically pi r squared. So therefore, since we know the intensity, the radius, we could figure out the power. The power will be that pi r squared times the intensity. So let's go ahead and calculate that. So pi times r, which is 3 times 10 to the power of negative 3 meters, quantity squared, and then multiply by our intensity, which is 2.0 times 10 to the power of negative 3 watts per meter squared, which yields an answer of 5.6 approximately times 10 to the power of negative 8 watts, or you could say joules per second if you wish. So now that we know how many joules per second there are, so many joules are being emitted per second, we're looking at a time period of 1 minute, which is 60 seconds. So to find the total energy, we're going to take that power and multiply by the time. Remember, power is work over time, or energy divided by time. So cross multiplying, we're going to get energy equals power times time. So we have that power of 5.65 times 10 to the power negative 8 joules per second multiplied by 60 seconds, which gives you an answer of 3.39 times 10 to the power negative 6 joules. Now just to note, if you look earlier in the notes, you'll see that the intensity is given as 4 pi r squared on the bottom when we look at that. The intensity is power over the area. But the reason why we're using 4 pi r squared in this formula is because if you were to have some sound that was just being emitted and it would be going out three-dimensionally, what you would see is actually basically concentric spheres. And the area, or cross-sectional area of a sphere, is given as 4 pi r squared. However, in example number 4, if you look at it, this is an eardrum with a certain radius, and so the eardrum would be basically a cross-sectional area of pi r squared. All right, that's it for example 4.